Hello, and welcome to PreCalc Lesson 16. Today we're going to talk about complex fractions and abstract equations, as well as some polynomial division. So let's start with this fraction, something you've seen before in Algebra 2. Now, the way we simplify this is actually pretty easy. It's just like how Jesus works in our lives. He doesn't work on the outside and work his way in. He works on the inside and works his way out. So how would I simplify b plus c over d? Well, I need a common denominator, and that's d. So it's going to become bd plus c over d. So this simplifies down to x over a plus m over bd plus c over d. Now, from there, I'm going to multiply this fraction and work on this guy. I see this denominator here. I don't want it there, so I'm going to multiply by d on the top and bottom of this big fraction. These cancel, and I'm left with md over bd plus c. So we zoom out once more, and now we're going to simplify this fraction. The denominator of this one, if the d's are gone, is bd plus c. So a must also have bd plus c on the top and bottom. From there, if I simplify it, I'm almost to one big fraction. It looks like ABD plus AC plus MD over BD plus C. My last step is to get rid of the denominator here by multiplying on the top and bottom by BD plus C. With those gone, that's my final answer. Not too bad. That should be a review from Algebra 2. Now, we see some more complicated ones in pre-calculus that look something like this. A over x squared plus b over x all over m over x squared plus k over xc. Now, remember that any fraction bar really is just like has parentheses around the numerator and parentheses around the denominator. So I have to simplify the numerator all the way first. If I'm going to add those two fractions, this one's missing an x on the top and bottom to have a common denominator. For this guy, if I'm going to add these two, this one is missing an x, so it can be x squared, and this one is missing a c. So if I simplify those, I get my big fraction bar in the middle. On top, I have a plus bx over x squared. On the bottom, I have mc plus kx over x squared c. Now, I'm going to multiply by the reciprocal of the bottom on the top and bottom. When possible, I am going to cancel. Remember that it's only possible to cancel if you have only multiplication. So for these ones that are added, there's no chance of canceling. So I can only cancel the x squared. All of these though, since this and that are the same, I can cancel those. And I'm left with my final answer of a plus bx times c, so that looks like ac plus bxc, all over mc plus k. X. Again, review from Algebra 2, but very important to be able to solve. Sometimes we get things that ugly. Now, this is often a difficult concept for students to grasp. So let's look at this one. We are going to solve this for C. So C is right there, and I have to solve this for C, which means that I'm going to move everything else away from C so that I can get C by itself. So my first step, a lot of students, honestly, they distribute V. You're making too much work for yourself, okay? If you divide by V on both sides, then V is no longer a problem. We have y over V equals a over x plus b over mc. Since this term is the one I want to get by itself so I can get to c, I'm going to subtract ax from both sides, or a over x. This side, they cancel. This side, I need a common denominator. What's my common denominator? Well, it has to have an x and it has to have a v. So this left side becomes yx minus av over xv. This equals b over mc. Now, this is where it gets tricky. And only under this circumstance can you flip both sides. And it is when you have a whole fraction bar on the left and a whole fraction bar on the right. Otherwise, you are not allowed to flip both sides. In this case, though, I have one fraction bar on the left, one fraction bar on the right. So nothing like this, but one single fraction bar, so I can flip those sides. Finally, I'm solving for c, so I want to get rid of m over b. I will multiply by the reciprocal. So these cancel, and I'm left with my answer. C equals bxv over myx minus mav. And that's that. Now the last part of our lesson is polynomial division. This is often really challenging, so we're going to do one difficult example and see if we can pick it up. We're dividing x cubed minus 2 over x minus 1. Now you guys should remember this from even Algebra 1, but let's review it one more time. Remember division, we use the division sign. The number on the bottom goes to the left. The number on top goes on the right, or in this case, the letters. Notice I've left a space here. You have to have each term represented. So I have x cubed, I need x squared, and I need x. Now, how many times does x go into x cubed? Or a better question might be, what is x cubed divided by x? That is x squared. Now I'm going to multiply x squared times x to get x cubed, x squared times -1 to get negative x squared. You will change the sign now, just like we would do in normal division, we would subtract, but you're going to change the sign using a different color. In this case, I've used red. I require you to change the sign with a different color. So x cubed minus x cubed is 0. X squared plus, or 0x squared plus x squared is x squared. I'm going to bring down the next term. Now what is x squared divided by x? Well, x squared divided by x is simply x. I'll multiply these, that gets me x squared. X times -1 is negative x. Again, changing the sign in a different color. And x squared minus x squared is 0. 0x plus x is x, bringing down the next thing, minus 2. What is x divided by x? That looks like 1. So I'm going to multiply 1 times x, 1 times -1, change the sign in a different color. And -2 plus 1 is -1, so I have a remainder, -1. And that, my friends, is problem set 16.